This is Eloy Rodriguez again, and we're doing another problem here. This one has to do with exponents. Let's see if we can solve a problem like this. The idea is that if 2 is raised to the 4m plus 8 times 9 raised to the m plus 2, and that's equal to 3m plus 2, how could we solve for m? So basically, this whole idea here is just to get things to have the same base on both sides of the equation. So over here I left this the same, right? And then you can see that this problem here, we have 9, right? Now 9 can be written as 3 to the second power. So we can write that as 3 as the second power, right, times m plus 2. Do you see that? And over here we look at 12, and I used what's called the fundamental theorem of arithmetic. It means that any whole number like 12 can be written as the product of its prime numbers. So I wrote it as 2 times 2 times 3. And all of that is raised to the 3m plus 2, you see? Now, so then what I have is, on this side, I have, I brought in, this is the same as it was before, nothing changed. But over here, I distributed the 2 through. So now I have 3 is 2m plus 4. And then over here, I just said 2 copies of 2 is 2 to the second power times 3. You see that? And then that power, now I can bring it up to here. So now I have the same thing. I got it repeated as before, but here I have it split up into 2. I have 3 raised to the, see it? 3m plus 2. And then I also distributed that 3m plus 2 next to the 2. So now I have a 2 raised to the 2 times the 3m plus 2, times 3 and 3m raised to the 3m plus 2. Now, take a look at what I got colored here. Now, I have 2 of this equation. On one side of the equation, I have a base. We call it base 2 raised to the 4m plus 8. And over here, I have another base 2, you see? But that's raised to the 6m plus 4. Then on this left side, I have a base 3, and then I have another base 3. So now we can compare our two bases, right? We have a 2 on one side, 2 on the other, 3 on one side, 3 on the other. So for these to be equal, that must mean that 4m plus 8 has to be equal to 6m plus 4. So that's what I said equal here, look. 4 plus 8 equals 6m plus 4. So I just subtracted 4m from both sides, so I got 8 equals 2m plus 4. You see that? So while I'm doing that, I just said, okay, so now I'm going to subtract 4 from both sides, and I have 4 equals 2m. So one solution is m equals 2. But now, that had to do when we were talking about the base 2. Now let's look at the base 3 with the green underline. That must be that 2m plus 4 has to be equal to 3m plus 2. So then, this is for the base number 3. This top one is for base number 2. So that means I've set those two equal to together. And again, if you take 2m plus 4 equals 3m plus 2, and then what you're going to do is I just subtracted 2m from both sides so that I got 4 equals 4m plus 2, and then I subtracted 2 again. There again, we got m equals 2. So now let's check the solutions. So I'm going to take this m, and I'm going to go back to my very original problem. You see that? I'm going to take the m and plug it into here. So you can see what I did, exactly that. That's 4 raised to the 2, because m is equal to 2, plus 8. And over here I got m plus 2, but m is 2, so I got 2 plus 2. And then over here I have 3 times 2, which is 3 times 2 plus 2. Coming down here, this is just 2 raised to the 6. Let's see, I got 2 raised to the 16. That should be 2. Okay, that's right, because 4 times 2 is 8, plus 8 is a 16, you see it? And over here I got 9 is 2 plus 2, well, that's 9 to the 4th. But on the right side, I have 3 raised to the 2 plus 2, which is 12 to the 8th. And when I sat down and figured it out, 2 to the 16th is 65,536. And 9 to the 4th is 6,561. multiplied together, you can see you got 4,029,981,696. And when you take 12 to the 8th, you get exactly the same. So I got this check mark, means that checks. Okay? And then the third problem, we have this absolute square root of something in parentheses squared. So normally the idea is that when you take a square root of a square, you have two solutions, positive and minus, or you can think of it as the absolute value of 60, square root of 63 minus 8. Okay, so I just took the square root. So I looked at it as saying, okay, the square root of a square would be like having two solutions, a positive and negative, although the number in there, if you'll see that, it's always negative. Because the square root of 63, you know that the square root of 64 is 8. So the square root of 63 will be less than that. So if you look at the absolute value of it, you can think of it as reversing the order as 8 minus the square root of 3. So it's always going to be negative, but the absolute value of it would be positive. So if I think of it as being positive, then the square root of 63 minus 8 plus the square root of 63 minus 8 would be 2 times one of these square root of 63's. And that in itself would be equal to the square root of 63 minus 16. Now, you could simplify it if you want, because 3 times 3 is 9, times 7 is 63. So, I mean, you could see that a 3 could come out. You have 2 copies of 3 that come out, and it becomes 6 times the square root of 7 minus 16. However, if you look at it as a negative answer, then we have negative 63. If I distribute the negative through here, that'll be the negative 63 plus 8 plus the square root of 63, and that gives us an answer of 0. And that's the whole ball of wax. Let me know if you have any questions. Okay, thanks. Bye.